Oh. Okay, I'm recording a new way today, so you're going to see the video looking a little different, but I hope this will be a fun experience. So first off, I want to teach you about circuitry. So to start with, what shape do you think I'm going to draw?
A
Circle. All right. So everybody, draw a big old circle. Okay. Next, I want you to start in the middle, that'd be the center, and go out like that. And then we're going to make a wedge and try to make it like mine. I'm trying to make mine so that the two radius will be equal, of course, but I'm also trying to make this arc here also be equal in length. And I think I kind of missed. Mine wasn't perfect, but try to make yours as close to equal, where the arc length, do you guys remember that that's what that's called? The arc length is the same as the two radii. All right. So now, if I do that right, then the angle in here, it's called the central angle. See if I can zoom in or stretch this thing. The central angle there is going to be, can anybody tell me? This is an ACT question.
The other two.
The angle there, oh, you're thinking that it's an equilateral, but that would be if this side right here, I'm going to change to blue. If I did this and made it an equilateral triangle, I agree, they'd all be 60. And it's close to that. It's very close to that. But it's the curved length. That straight line length, do you know what that's called? The chord length. So the blue one, that would be called a chord. C-H-O-R-D. Okay, but we don't want that length. We want the curvy length. So, bottom line, that is not 60 degrees, but it's really close. It's called, this is an ACT question, you're learning something, pay attention. If those things are all the same, then that angle is called 1 radian. Remember the radian setting on your calculator where you could switch between radians and degrees? That's what a radian looks like. Okay, that angle right there, that's not 60, it's really close. It's like 59 point something. It's just annoyingly close to 60. In fact, if I put 3 of them side by side, so I go like this, and there's another radian, and I do a third one, it's very close to having been all the way straight across like this. In fact, how much do you think that little gap is? Somebody theorized based on you knowing that math often kind of works out to cool things. Yes?
Pi degrees.
Exactly, pi. Not just 3, 1 radian, 2 radians, 3 radians. How much do you think that part is? 3.14. It works out perfectly. All right, so there is 180 right here, and that's also known as pi 3.14 radians. All right, the reason you care is because, a second here, I'm gonna pause. All right.
Not making it harder.
So, I'm going to give this a try. We're in the learning mode here, and it's okay. I'm going to make a new one. And this time, I want you to make a 30-degree angle. Let's make a brand new one, brand new circle. Let's make it 30. That right there, 30 degrees. Okay? Okay, so if that's 30 degrees, then the question would be, how long is this arc right there? Well, it's not a radian. Remember the deal on radians? Is the radiuses would be equal, of course, but the curvy line would have to be the same length. And you can tell by the drawing, it's not going to be the same length. And the angle is anywhere close to a radian. Remember a radian was about 60? A little tiny bit less? Okay, so this is not a radian, and so this is not the same as the radius. All right, so how do I find it? There's a formula you need to know. S equals theta r. And S stands for arc length. I really wish this was an A, because S and arc don't go together in my head at all. Like, why would they? It's like we have 14 cows and we're going to call them 14M. What? Why isn't it C for cow? Or okay, M for moo. All right, fine. You've made it tighter. I need something like that for the S. All right. So anyway, that S is the arc length. Theta is the angle. Pay attention. Pay attention. But the angle has to be in radians. So I cannot use the 30 right there. I got to change it to radians. I'll tell you how to do that in a minute. And R is the radius. Radians, radius. Okay, you got your new formula for the day. Now, how do I do this? Well, if I told you that this radius was an 8, that'd be fairly simple. Then I could put the 8 right here, but then I still need to do this radians thing. How do I get that to be radians? 30 degrees. How do I get it to be radians? All right. Now I need to pause for a second. Okay, so I'm going to sidestep for a moment and talk about how I can change 30 degrees into radians. Think of it this way. If I was all the way open, that'd be 180 degrees, also known as, we figured out, pi. Well, then what if I was only halfway open? What if it was like this? Would you agree that's 90 degrees? And therefore, logically, half pi. Very good. Half of pi. What do you think this would be? I'll use a third color. Right there. Would you... Oh, that's terrible. Undo. Sorry. That is about a 45 degree angle. Would you agree that would be 45 and how many radians? Pi over what? Pi over 4. All right. Now, I have learned this trick and I hope that it works for you. If I asked you where 5 pi over 4 is, that sounds really scary. But would you agree that 5 pi over 4 is 5 pi over 4s? This is where 1 pi over 4 is. If I go up another notch, that's where 2 pi over 4s is. Because 2 pi over 4 would be the same as a half. And then 3 pi over 4 goes to here. And 4 pi over 4 would be the same as pi, wouldn't it? And so then 5 pi over 4 is one more notch. And this is where 5 pi over 4 would be. And it's technically, this whole angle there is 5 pi over 4s. Would you agree that's an angle that's bigger than 180? Would you agree it's 180 plus one more little notch here, and that those are probably 45s? Know what I mean? These are 45 degree angles, right? 2 45s, 3 45s, 4 45s, 5 45 degree angles. So this is 180 plus another 45, which would make it a 225. Also known as 5 pi over 4. How about this spot here? What would that be? 6 pi over 4. Just do it that way. And yes, it can reduce, but it's a great way to do it. And then what's this spot? 7 pi over 4. And then if I got all the way back to the beginning, would you agree that would be the same as 8 pi over 4? Also known as 2 pi. Does that make sense to you? This spot is 0 degrees, as in you haven't even opened up an angle yet. Or if you open up all the way around, that's 360 degrees, also known as 2 pi. Two pi what? Radians. 2 pi radians. All right. So here's the goal. If I say go to 2 pi over 3, that someday will be as easy as me saying go to where 120 degrees is. Because you'll memorize these and you'll figure out where they are. All right, so let's put the center in your circle. And put 0 over here at 0 degrees. What do you think 30 degrees would be in radians? Well, it's 30 degrees. What would it be in radians? Yes?
1/6 pi.
Yes. pi over 6 or 1/6 pi. I like the 1 pi over 6 thing because then that easily leads to 2 pi over 6. Get what I mean? The next spot would be 2 pi over 6s. What's the third spot? 3 pi over 6. What's the fourth spot? 4 pi over 6. 5 pi over 6. What do you think that spot's going to be? 6 pi over 6, also known as pi. And then how about 7 pi over 6? That'd be down here. Now, use your big brain and figure out how many degrees that is. It's more than 180, right? How much more than 180? 110, are you sure? 180 plus some more. There we go, 210. Would you agree that 7 pi over 6 is the same as 7 pi over 6s? That's the same as 7 pi over 6, right? And aren't pi over 6s 30s? 7 times 30, 210. It's 7 pi over 6s. And pi over 6s are 30. All right. Now, some of you don't like that way, and some of you might like a normal math way to do this. So I'm going to give you one more example of how to change like something like 210 into radians. You multiply by a fact. I'm going to go to the side here and take 3 feet. What if I wanted to change that into inches? Would you agree there's a fact about inches and feet that I could use? And it is what? But would I put the 1 foot on top? No, you put the 1 foot on the bottom, and then you'd put the 12 inches on top. You get what I'm doing here? And the feet would cancel, and so then I'd make 12 times 3 is 36 inches. That's how you convert something. So let's do that with radians and degrees. Radians is how many degrees in a radian? Or should we do, how about this? I'm going to tell you, I'm going to put a 180 down here. And you tell me what you think I should put on top. Pi, because pi is 180, right? Now, do you get that the degrees will cancel? And all you got to do is reduce 210 over 180. I know this is a lot. There's a lot to learn here, but you can do this. So if you can factor it, you should, right? So how do you factor 210 degrees? I'm going to pause for the video for a second. All right, so we got a little distracted there, but now we're back. And we were changing 210 pi over 180. And I like to factor, so I say if you can factor it, you should. So what does 210 factor into? 7 times 30. 7 times 3 is 21, right? 7 times 30 makes 210, doesn't it? Why did I do that? Because what do you think I'm going to do on the bottom?
180 goes in 30.
So I would change 180 into what times what? A whole bunch of 30s. How many 30s? 6 times 30. And that means the 30s can cancel. 7 pi over 6. Whew. That's what you got to get good at today. It's not that bad. It really isn't that bad. Okay, so let's say I said 2 pi over 3. Convert it from, what does that look like, degrees? No, because it doesn't say degrees on it. So it's obviously not degrees. It must be the other thing. What are those called again? Radians. All right, so that's radians. So then you're going to multiply by, and let's use the dice of destiny. So I'm not picking on anybody in particular. John? Of course, I could say these dice said anything. Row 6, person 3.
Wow.
Go ahead. Okay, I'm taking it away from somebody who actually is supposed to be called on, which is actually you, back corner, Mr. CA. So, what do you think I should multiply by? 12 inches over 1 foot? No. We're trying to change radians to degrees. That was a distractor answer. Oh, that's all right. What do you think the 2 numbers we should use? Hint, one of them's pi. Pi on the bottom. 180 on top. Awesome. Cancel, cancel. If you can factor it, you should. CA, factor 180 into 3 times something. Because then the 3s will cancel. 180 turns into 3 times 60. 3s cancel. Boom, boom. Final answer.
120.
So did you get that we changed 2 pi over 3 into 120? Do you think you could do that?
No. Let's see.
No, oh, come on.
That's an encouragement.
Let's see if you actually can. One more time. 7, nope, 11 pi over 6. It's a certain number of degrees. Now, this one requires a lot of, if you can factor it, you should. Could you tell us what to multiply by?
180
180 over pi is correct. How did you know to put the pi on the bottom?
we cancel.
So that way it'll cancel. Very good. Okay. Now here's the factoring part. That's a little harder. EL. That 180. Hint. Use the fact there's a 6 on the bottom.
Yeah. So 6 times 4.
6 times 30. Awesome. And now I have 6 times 30 so that the 6's can cancel. Boom, boom. And who here can multiply by 11? You remember that trick? So what's 30 times 11? 330. Very good. So 330 is your answer. See, no calculator needed. It's a good thing because you want to have a calculator in this next test.
Oh, yeah.
Why?
What?
But the calculator's my friend.
Anyway, you'll be fine.
You know, half of us are the people who double check 4
not
plus
wrong.
4 on the test, right? No, it's not.
No, I do that too.
Thank you.
Have low self-confidence with multiplication.
4 plus 4 on the test on your
All right.
You can't trust yourself.
The last thing I have to teach you.
I've checked like 4 times.
Do you get if you had a whole circle that, oh, this is the worst circle ever. I'm going to have to learn how to use the circle tool on this thing. Let's see if that's a circle too.
Circle and a square.
Hold on. Hold that thought a second.
4 down, 4 items.
4 items down from the marker. The little
Aha! I don't see a circle.
Nice job, Brandon.
Big arrow there.
How about this one?
No, that's a point.
That's the point.
Oh, it's just a pointer to show where I'm top touching. Okay, all right.
Go back to the shape.
That one?
Yeah.
I think you would click one. That's the point.
Try to start.
Yeah.
No.
Try it, try it.
Ha-ha! All right. Okay, yay, it's a circle maker. Okay, so I'm just proud. Okay. Whoa, what just happened? Not good. Still recording? Yes, okay. So, sorry about that. I need to get a pen out, and let's go with green here. We're going to go from the center out. And now here is a typical question for today. Find the area of this sector of the circle. And wait a minute, didn't we just learn how to find this thing? Yeah, that's different. That's not a sector. That's called the what again? And don't say chord, because that's similar but different. Arc. Okay, but what if we want this whole sector? Would you agree it's some fraction of the circle?
Yeah.
So it's just pi r squared is the whole circle, but we need a fraction of that circle. And would you agree that it's, well, let's say that it's about 30 degrees there. Let's say that that was 30 degrees in there. That angle, the central angle it's called. I'm going to make it black so it stands out over the green. Okay, so if that's a 30-degree angle, then I take 30 over, what percentage of the circle do I have? 30 out of 360. Doesn't that make sense to you? Because the whole thing would be 360. If I had the whole circle, I'd have 360 out of 360, which would just be 1 times my circle. Okay, so I have 30 out of 360 times pi r squared. I, of course, need to know the radius. Let's say the radius is a 12, and then I'd have a 12 right there, and then there's my final answer. I just have to simplify it a little bit. If you can cancel it, well, I don't have that rule in my life, but yes, canceling is a good thing. So 3 out of 36 reduces to 1 out of, can anybody do that? 12. And then this is pi r squared, 12 squared is 144. If I had to leave my number as exact, I would say it was 144 pi over 12, but I can, if I can factor it, I should. That's really 12 times 12, right? So then one of these 12s cancels, so it's 12 pi. All right, moral of the story. It's a fraction of the circle, so it's a fraction of pi r squared. What's the fraction? It's, if it's in degrees, I'd take it in degrees out of 360. All right, I'm going to do a bunch of back in time stuff here, but before I do, question.
What is that equation trying to find?
This equation is finding the area of the sector of the circle.
Okay.
All right, so imagine for a moment that I was given it in radians, though. I know that'll annoy you. Instead of having, hold on just a second here. You know how to get rid of this inspector thing? I thought so too. I'm tapping off of it. It's not going away.
Inspector Gadget.
Drag it away. Like drag it away.
PTSD.
Oh, I like it.
No kidding. Wasn't even on the
All right, I got it off to the side anyway. All right. Okay, so last type of question. Ready? You got a circle. Wait, I should use my new circle tool. That feels different. Oh, that's this one. There we go.
Let's say 13 days.
Okay.
You do?
And
Good, I remember watching it.
shh, a little too much talking. Okay, so this is about pi over 3. What? Can anybody tell me what angle I was going for there? What's pi over 3? You got it memorized yet? 60. All right. So I would recommend pi over 3 being 60 is one of the ones you memorize. Pi over 2 is another biggie. That's half of pi. Can you do it? 90. Very good. And there's one other pi over that's really handy. Pi over 6. And that's what? 30. Because then you can just double that one and say 2 pi over 6 is 60, which is the same as pi over 3, right? All right, so anyway, if you memorize these 3, that'd be really smart. Plus, of course, the one we use for conversions, that pi is 180. Memorize those so that they come naturally. So when I see pi over 3, I can go, boom, that's 60. All right? Now, what if I wanted to find the area of this little sector of the circle? Would you agree it's not the whole circle, which is pi r squared? It's part of the circle, so it's a fraction of that circle. All right, so what fraction is it? Well, I could say 60 out of 360. Or who could have done that an even better way so I never even had to convert? Ooh, you're really, really close. You want it in radians. What was it for an angle? Pi over 3, not over pi though. Pi over 3 over
2 pi.
2 pi. Now, personally, I feel like it's actually a little easier if you put them in degrees, because 60 over 360 sounds easier to reduce than pi over 3 over 2 pi, but it is the same. Let me just break it down here. Pi over 3 divided by 2 pi is the same as times 1 over 2 pi. Pi's cancel. Comes out to 1/6. Does that seem believable that I have 1/6 of my circle? All right. So 1/6 of pi r squared. What's the r again? I never said an r. Let's say I say the radius is 8. Then it's 1/6 times pi times 8 squared. All right, let's say that the question hadn't been area of the sector. What if it had been how? I have to learn how to do a lot of undos without touching this inspector box.
You can't use the eraser thing when you're recording.
All right, sliding up. Last one, promise. Ready? Here's a typical sector. If you wanted to find the sector or the area of the sector or the length of the arc for this, where this is 7 and this angle right here is 45 degrees, you should be able to tell me both the area of that green sector of the circle. You can leave the answer as 12 times pi times 49, that kind of thing. The area of that sector of the circle, and find me this arc length, which hint is called S in the formula for that. The arc length and the area of the sector. See if you can find them both, and then compare them with the kid sitting next to you. pause the video while we give that a try. All right, let's see how you did. My first thought, I'm going to write the formulas. Did you know it was S equals theta r? All right. And the arc length I didn't know, but the theta I knew. It was 45. Hopefully you did a little conversion and figured out pi over 4. If you have trouble with that, I'll show you over here. 45 got timesed by pi over 180. And once you reduce it down, the degrees canceled down until it became pi over 4, or 1 pi over 4. Because 180 is really 4 times 45. And if I do it that way, you might be able to see that the 45s cancel, and I'm left with pi over 4. Okay, so pi over 4 times the radius, which is 7. So 7 pi over 4. How many of you had that for your arc length? Raise your hand if you had that. Okay, awesome. Do you have a question?
Can you not do like whole numbers for the arc length?
Arc length can be whole numbers, but since pi is something that's kind of built into our formula because it's going to be in every radians. Now, here's the thing. I know you're thinking in the real world you'd never tell somebody like the length is 7 pi over 4. That's a weird length. You can always times by 3.14. It's totally okay to use. If you have a calculator, you just go 7 times 3.14 divided by 4. So you can get real numbers out of this. They don't have to have a pi in them. All right, so there's the arc length. How about the sector area? That's this area of this wedge of the circle. Well, I like to think of it as it's part of pi r squared. And what part of it is it? Well, 45 out of 360 is the easy way, in my opinion. If you want to use radians, you would have said that radians, which is pi over 4, over how many is 360? 2 pi. And again, that's kind of weird. Not many kids are going to do it that way. Pi times r squared. And r is just 7, so we just stick in a 7 right there. So I'm going to do it with the degrees. And I'm going to simplify 45 out of 360 as 1 out of 8. So that's 1/8. I think I did that right. Can anybody verify that? Okay. 1/8 of pi r squared, which is pi times 7 squared. So that would be 1/8 of pi times 49, which would also be 49 pi over 8. That's an exact answer. If you really like decimals, you could go 49 times 3.14 divided by 8, and that'd be your area. So the first one was arc length, second one was area. All right, so now, one more thing that's on your assignment, but I'm going to gloss over and not assign you because I don't think it's that important, is I just want you to not feel like, oh, we skipped this thing and it must be important and yet we skipped it. It's not important, but I'll show you. If they give you 210 degrees, do you remember that there was also that thing called minutes, like 20 minutes? That meant it was 210 degrees plus 20 over 60. Remember this? And then we got a decimal. It's just a funny way of writing 210 point something degrees. They did that with minutes. What do you think they're going to extend it to now? What's after minutes? Seconds. So you could do 20 minutes, and then you could do 30 seconds. Well, then that means 20 out of 60 plus a little tiny bit more, right? 30 seconds. Well, then how many seconds are there? Whoa, this is weird. It's my little alarm going off, but it's going off in my ear because I have the, can you even see I got this in? You know why I have it in? Because it's recording my voice through that. Because otherwise it would record my voice through the iPad, which whenever I touch the screen and I tap it with the pen, it makes a really loud tapping noise because it's like you're tapping right on the microphone. That's why I have to put this in, because then it records my voice this way and it doesn't hear the tapping noises. I tried it once, it's like crazy. It's like really loud, like all the time in the video, and it drives you crazy. So that's why I put in this earphone. Okay, so how many seconds are there? Well, this was how many minutes there are in a what? In an hour. So how many seconds do you think there are in an hour? That's how you do it, but I don't think it's that important, so we're just skipping over them. Okay? This would be out of 3,600. This would be out of 60. And again, you got to calculate. If I was doing something like this, I'd grab a calculator. And this is mostly supposed to be not calculator, so let's not waste our time on those. So I'm going to find the homework and I'll put it up here. Actually, that's one of the challenges with doing this with the iPad. I'm going to just be able to tell you which problem numbers it is because I can't show it to you. So I'm going to pause for a second here. Okay, so we found it. You're going to do problems 37, 38, and 39. And then on the next page, there's 3 more problems. We're going to do those 3 also. What's the next page say, ma'am?
57.
A little louder. 57, 58, and 59. Those are the 6 questions I'd like you to do as homework over the weekend. I think you'd probably agree that's a fairly small assignment. You can handle that. Let's look at number 37 and do it together right now before you forget how to do this stuff. You get 12 minutes. I know you're tempted to just go do something else, but if you get one problem done in your homework, it's going to seem so much easier. Okay, OC, would you please read me number 37?
This is pi. Oh, convert the angle from radian measure into degree measure.
Convert from angles. Okay, so what did they give you? What angle?
Pi.
They gave you pi, and they want you to convert that into radians. Can I just say, I know pi is 180? Yes, but I'm going to show you math-wise what we should multiply by. Take a wild guess.
180 over
180 over pi. Cancel, cancel. I know it's 180, and it's okay if you just write 180, but I'm trying to show you we can use our system, multiplying by a fraction, to get all of them. Okay, now what's number 38?
Negative 2 pi over 3.
Negative, that's weird. 2 pi over, what?
3.
3. Now we have directions for angles. Never had that before. Let me show you for a second. Here's where our normal ones, we were drawing this way. Hold on. Not that one, that one. When we'd make an angle, we'd go like this. We'd go up until we'd stop, and we'd say, there, that's 90 degrees. Take a guess where negative 90 would be. I'd go the other way.
Why
What's the
do
answer?
we go counterclockwise?
That makes sense. Because why not?
'Cause it's making
So that would be a negative 90 degree angle. Negative 90. Okay? All right, so back to the one we were working on, which was negative 2 pi over 3. Don't worry about it, it's just negative. So I just multiply by pi over 180 or 180 over pi. And if you do it wrong, you'll quickly realize, wait a minute, I can't get those to cancel. So you just have to undo that and go back and try to put the pi on the bottom instead. And that cancels that. And then if I can factor it, I should. I'm going to make this into 3 times 60. And that way the 3's will cancel. Negative 2 times 60 makes negative, what? 120. All right, I've done 2 out of your 6 problems already. On 57, they want you to find the angle. No, they want you to find the arc length. That's this formula. And they want you to find the area. That's this formula. Area equals some fraction of, which you can use. I like to use degrees, but if you want to do it in radians, I totally can be fine with that. And then times it by pi r squared. I like to do degrees out of 360. But you can do your radians out of 2 pi. Okay, there you go. Those 6 questions. And that's all I got for the inaugural first recording from the iPad. That was a big moment.